So we will just write down our expressions that we're dealing with. So the equation of motion, m plus m s double dot plus my L squared over m L minus s cubed minus mg equal to 0. So this is the equation that we're dealing with. Okay. So now we're going to do the same trick. We're going to multiply everything by s dot. So I have an m plus big M s double dot s dot plus L squared s dot over m L minus s cubed minus mg s dot equals 0. And when I have this form, then I can integrate with respect to t. And we have the same kinds of conditions before, where we have s double dot, s dot, you integrate with respect to t, and so this becomes an s dot squared, and so on. And this integral ends up reducing to one involving ds and also ds here. And so when we do all those integrations, I won't go through the steps. You can work this out as an exercise. But I have 1/2 m plus m s dot squared plus an L squared over 2m L minus s squared minus mgs is equal to a constant. And when we have it in this form, we'll recognize this is the total energy of our system. So we have the translational kinetic energy, we have the rotational kinetic energy, and we have the gravitational potential energy. And that has to be equal to a constant. So here again, we now have the conserved energy in the system is naturally coming out of solving the Lagrange equations. We didn't put this in, it comes out. So it's remarkable that we have not only the conservation principles of momentum that naturally arise from the Lagrange formalism, but also the energy, which naturally arises from this formalism as well. So just one more step that we'll do. If we were asked to find where the equilibrium point would be, so just to refresh your memory, at equilibrium, s double dot is equal to 0. So we go back to our original equation, and we have then the expression of L squared over m L minus s, and I'll put the subscripts on here, equilibrium cubed has to equal to mg. And so we could then solve for this distance for the equilibrium in terms of the angular momentum in the system and the gravitational force. So essentially, this is the balance point between the pull of gravity on the large mass and the angular momentum. And so Also, with the Lagrange formalism, solving for equilibrium points becomes a very straightforward thing to do as well.